So this was the validation part, checking the normality, is it really linear and all. Now to actually telling the story about what's going on based on the model. I already told you further up that we could do, that was all the way up here, we didn't, that we could do testing by just looking at the outputs, right? We can also do confidence and prediction intervals for the plane, for the model, as we did last week. And it's very easy this week. It may look weird, but it's very easy. It's put in method 6.9, and it's a non-formula method. It's a method that tells you we are not going to give you the mathematical formulas for doing prediction and confidence intervals. You had those formulas last week for the simple linear regression, but hey, it's too complicated to write it out now. But it's easy to extract it from R, exactly as you were taught last week, by using the prediction, the predict function, and there are options for confidence and prediction. For instance, if I have my model, where I have whatever is in my model, I can, if I have some data, and here I create a data frame with some values for temperature, some values for wind, some values for square of wind, some values for radiation. I can plug those into my model, and then I can either ask the function to give me the confidence intervals, or I could ask the function to give me the prediction intervals with the same rules for interpretation as I taught you last week, the distinction between prediction and confidence intervals. And then we can plot them. Let's not do that now. That was confidence and prediction intervals. And a check question. I'm only moderately happy now. The confidence interval is always the narrow one. The prediction interval is always the larger ones. Maybe I can just hope that some of you got confused about the negation of the statement, where it's easier to do a truth than to do a false somehow. Anyway, confidence intervals, and let's go back to the case from last week. That's I prepared how to verbalize it in that setting. The confidence interval would express, for instance, my attempt of estimating the mean weight for people of height 175 centimeters. I could use my regression model to estimate the population mean weight. I should maybe say subpopulation mean weight for people of 175 centimeters. That's a pretty magic thing of a linear regression model, that even though I didn't sample even a single person of that height, I still have a model that allows me to estimate the mean weight of such people, even though I didn't even measure one of the guys. And I can do that if I believe in the linear regression model, for obvious reasons, right? And I can estimate the mean height for a whole subpopulation. And if I want the uncertainty for that estimation of that mean height, for that mu, it's called a confidence interval. I can get that as precise as I want. It's just a matter of increasing the number of observations to have. If I put in 1,000 or 1,000,000 observations, the precision, the red one, would be exactly precise. I can get that as precise as I want. The green one, the prediction interval, that's a more ambitious way to use a linear regression model. And this is a way that you use if you're a production company and you check your tablets at Lundbeck and you go through an NIR spectrum or something like that, and you make a regression model to predict the amount of active substance in your tablet on your machine, on your running, on your production line, you want to predict not the mean of all tablets. Of course, that should be on target, but that's not very ambitious. No, I want to predict the individual tablet, because all individual tablets should be more or less on target. Otherwise, we kill all people due to high levels, and other people are getting killed because they don't get anything. So individual tablets must have the right level. So I want to use a regression model to predict individual tablets. That's a high ambition. And having this ambition of predicting individual people or tablets, I get an additional uncertainty which comes from the variability of individual tablets or individual people. I could never do better than the individual biological variability. If I want to predict one person's weight by this model, the biological variability of weights for people would set a limit to how precise I can do it, because I could never get out of that. So that's the distinction between using a line for estimation, confidence intervals, or using a line for prediction, individuals. They are used for both in real life applications. So both can be important. That's why you see in R, both of them comes, in the same way, just a matter of how you choose the option. Mellow Mike is still in business.